Now, next topic natin is distributed normal loads. Okay. Resultant naman ng distributed normal loads. So, pag normal loads, normal loads, perpendicular dun sa may surface ng structure or ng rigid body. Okay? So, meron tayong dalawang types. Ano? We have the surface load, and we also have the line load. Okay. So, kapag surface load, ibang example natin ng surface load. Pag surface load, an example ng surface is yung slab, yung flooring, yung slab natin. Okay. Yung surface load, ano ba yung mga kinakarry ng slab? Sometimes yung finishing like tiles. Okay. So yung tiles natin, so surface load yun. So parang ito yung sample natin. So it would now parang pressure yung kanyang or stress. Okay. So yung weight ng tiles natin, since surface siya, spread all throughout the flooring or dun sa slab natin. Okay. So yung loading niya ay paganyan. Ito yung itsura ng kanyang loading. Okay. So from the term distributed, so the load now is distributed all throughout the area of the structure, or yung in this case example natin is a slab. Okay. So pwedeng tiles yan or finishing ng flooring. Ibang examples. Another example is yung tangke ng tubig. So concrete, for example, yung tangke ng tubig mo. So yung yung slab niya, so yung tubig niya sa taas would now exert some weight doon sa may flooring or sa may slab, but it is distributed. Okay, it is distributed. So what we have discussed before are we call those point loads. Point loads. Ano yung mga point loads? Yung mga concentrated loads. Yan, ang tawag natin dyan. Mga force lang na ganyan. Okay? But in many cases naman, some cases, distributed yung load natin. Okay? Distributed yung load natin. Just like what I said kanina. Like tiles, floor finishes, yung tubig, dun sa may slab ng tangke. Ano ba? Yung ceiling sa may flooring, yung weight ng ceiling natin is distributed dun sa slab. Okay? So, how do you compute now for the resultant? So, i-compute natin itong surface load na yan. I-convert natin yan sa iisang force lang. Okay, how do we do that? So, for surface loads, the resultant force is just equal to the volume. So, take note, volume nito. Volume ng loading natin. So, if this is the length of the surface, ito yung width ng surface natin. Of course, yung height nito ay usually ay omega, yung small letter omega or small letter W. This is now the intensity of the loading natin. So, kapag surface load, usually, nasa pressure yan or stress, kilopascals, pascals, PSI or it is pounds per square inches, and other units for pressure or stress. So, the resultant is just the volume. No? So, in this example, this is equal to length times width. And then height niya, of course, is the intensity of the loading, which is small letter omega or W. So that's how we solve for the resultant. So for surface loading, the resultant is simply the volume of the load. Next naman, ang isang example ay isa pang the other one, yung line load natin. So, line load, ano naman yung line load? Yung line load, examples ng line load, usually na-applied yan sa mga beams, no? beams and columns kasi yung width nila is very small compared to the length. Okay. So, example ng line load natin, yung mga beams usually carries yung wall, no? Yung wall na pwedeng hollow blocks, pwedeng wooden wall. Okay, so pwedeng masonry. So, yun, those are examples of of loads, no, na applied sa mga ganitong situations. Ano ba ba? Aside from hollow blocks, what else? Sometimes we also simplify, you know, para ma-simplify yung ating solution. For example, dun sa surface load natin. Sa surface load, since kung distributed naman yan all throughout the surface of the slab in this case, or yeah, the flooring or slab, sometimes to simplify yung design or analysis ng slab, we only consider one strip lang, or that is one unit strip, that is 1 meter or 1 foot. No, so that yung volume niya, yung width niya later on will just be equal to 1. So that if that is the case, I can analyze this as a line load na. So magiging line load na lang siya. So to simplify the analysis. Okay? Sometimes we do that sa design ng slab. Sometimes we also do that in the design of dams, no, sa water resources engineering. Now for line load naman, so line loads, example, hollow blocks. Yun yung naisip ko ngayon. O sometimes, ano ba example ng line load in real life? I can think of any example this time. But you will deal more of this one sa mga ibang subjects natin. Kasi usually, we convert yung mga, usually we analyze mga line loadings later on. No? Ayan. Sometimes we simplify yung surface load, sometimes we simplify those things and analyze, design na line load na lang. Okay, para ma-simplify yung analysis and design. Okay, so line loads naman, if this is the length, example, rectangle yan. So hollow blocks lahat yan, nakapatong sa isang beam. Okay, so line load yon. And this is the intensity. So the resultants, i-convert lang natin yan sa isang force resultant. So the resultant is equal to the area naman of the loading. In this case, we have length times the intensity, small letter omega or W. Okay, so that's how we solve for the resultant. So for surface load, volume. For line load naman is the area. Now, saan naman yung location ng resultant? The location of the resultant for both surface load and line load is the location would be the location or line of action is the centroid of the area or volume. So for rectangle, ito yung base height. The center of this is simply equal, yung location ng center, this is it's B over 2, and this is h over 2. So the center of a rectangle, well, rectangular yung ating yung line load. So yung centroid niya ay that's b over 2, b over 2 from this axis or from this axis. Okay, for ano ba ibang klaseng loadings? For triangle, halimbawa may triangular load yung beam natin, triangular yung loading. Line load din lang naman. So triangle yung line load natin. This is the length and this is the intensity. So again, the resultant is the area. This is 1/2 L times yung intensity W. Okay? And the resultant is yung centroid ng triangle. So, ano yung centroid ng triangle natin? Okay. This is the base, this is the height. Dito yung center niya. Nandyan yung resultant natin. Okay. So, that is B over 3. From ditong axis na to, And this is H over 3, which means ito ay 4/3, 3. This is 1/3 of H. This is 1/3 of B. This is 2/3 of H ito. Kapag dito yung reference point natin in locating the center, this is 2/3 of H, and this is 2/3 of B naman. So kapag triangle, ang center niya 1/3 from the base, no? So ano ba yung mga shapes? So I think you have discussed this before naman na nung geometry, no? So if you don't nakalimutan niyo na yung mga location ng centroids ng mga regular shapes natin, please try to review yung geometry. I think this was also a topic sa integral calculus, kasi one of the applications of integral calculus is yung pag-solve ng centroid ng areas, pati na rin moment of inertia. Ayan, so ganun yung kan natin. So for distributed normal loads, okay, for surface load, ang resultant is simply the volume, and for line loads naman, the resultant is simply the area, and the location is the line of action of the line of action of the resultant is the centroid of the volume or the area. So ganun lang kasimple pag-solve ng resultant kapag distributed normal loads. Now let's try to solve some illustrative problems here. Okay, so a beam is subjected to a system of loads that can be represented by the load diagram shown in the figure. So this is the load diagram. Ito yung beam natin. So medyo irregular yung loading niya, no? Okay. Determine the resultant of this system of distributed loads and locate its line of action with respect to this left support of the beam. So ito yung support ng beam natin, left support. Okay, so nasaan daw yung resultant force natin from the left support or from point A. So isolve natin yung resultant ng force. Ano yung resultant? Again, for line loads, that's the area of the loading. So meron tayong trapezoid at rectangle. So for these cases, to simplify the analysis, no, i-divide natin siya into regular shapes para mas madali. No? So divide natin. Nakalimutan ko yung ruler. To regular shapes. Maybe eto gawin natin isang triangle tapos rectangle. Ayan. Oh no. So isang triangle ito, rectangle. So ang gagawin natin, i-solve natin yung resultant ng triangular loading, line load. I-resolve natin yung resultant ng rectangular loading. And then after which, yung sum nitong dalawang resultants would be the resultant of the entire line load. Okay. So, para mas, although you can solve naman for the area na kasi meron naman na siyang given na dimensions, but just to simplify, no? Okay. So, ito na. Yung red na lang nilitin ko. So, dito yung, let's say, centroid ng triangle natin. Nandyan yung result, i-solve natin yung resultant niya. Let's say this is F1. Yan. And then, yung resultant ng rectangle. Siyempre, ang centroid niya nandito sa gitna, no? This is F2. Ayan. So that the resultant is somewhere here. We don't know kung ano yung resultant niyan. And it's located, let's say, at an x distance from yung left support natin, or from point A, x yung resultant natin. So the resultant is simply the sum of F1 and F2, or the sum of the resultant of the triangular loading and the resultant of the rectangular loading. So let's first solve for F1. Is it visible in the video? Yeah. So F1 is equal to the area of the triangular load. So ang area natin, area ng triangle, 1/2. Yung base natin is 4 feet. Height natin is yung height ng yung intensity ng line load natin. Tingnan niyo. This is 500, pero hanggang dyan yan. 500 papunta dito. But yung triangular load natin hanggang dito lang siya. Kasi kinat natin yan. Bale, ito na lang consider natin na rectangular load later on. Okay? So, ikat natin. So, this becomes 250, yung triangular load natin. It's 250. Kasi 250 yan, ano? 500 yan. So, 500 minus 250 is 250 pa rin. Is 250. Pounds per foot. Yan. So, per foot. Sorry. Okay. So, that's 250 pounds per foot. Cancel yung foot dyan. So, F1 is equal to ilan to? 500 pounds. Okay. Next, how about F2? So, F2 is the area of the rectangular load. Rectangular. So, area ng rectangle, very simple. That is base. That's 4 plus 3.5. That is 7.5 feet. Times height natin, yung intensity, that is 250 pounds per foot. Okay. So, ayan. And that is equivalent to 1875. Is that true? Pounds. Okay. So, that's F1, F2. So, the resultant, yung resultant natin, syempre, both are downwards. So, downwards din yung ating resultant. Okay. So, yung resultant natin is just the sum of the two. No? F1 plus F2, that is 1875 plus 500. It's equal to 2375 pounds. So, yan yung resultant natin. Ito siya. Okay. So, next, saan natin ilalagay ngayon yung resultant force so that para maging equal siya sa system na ito, sa original system natin. So, nasaan yung resultant force natin? So, ilolocate down natin yung resultant force from the left support or at point A. Okay? So, again, we're going to use the principle of moments. So, ano yung principle of moment natin? Yung dapat yung moment ng resultant force, okay, about a certain point, should be equal to the moment of the original force system about the same point then. Okay, so in this case, point A. So, summation of moment, yung moment dapat ng resultant force at point A should be equal to the summation of moments at point A. Okay, so yung resultant force natin, so the resultant force is 2375 times yung moment arm niya from A is X. Again, that is clockwise. So, clockwise yung moment created by R about point A. So, that is positive. The next, that should be equal to the moment of F1 about A plus the moment of F2 about A. Okay? So, ano ulit yung F1 natin? F1 is 500. So, ano ngayon ang moment arm ng F1 about A? So, what is this distance? Ayan. That is 1/3 of, again, centroid ng triangle. 1/3 nito. Okay, 1/3 nitong base natin. Base natin is 4. So, that is 4/3. So, 4/3. 1/3 of 4, or that is 4/3. Okay? So, plus yung moment ng F2 about A. So, again, F2 creates a clockwise moment about A. So, that is positive. So, F2 here is 1875 pounds times its moment arm about point A. So, anong moment arm ng F2 about point A? So, half ng rectangle natin. So, this is 7.5 divided by 2. So, 7.5 over 2. Ayan. So, we can now solve for X, location ng resultant force natin from the left support or point A, and that is equivalent to 3.241 feet. Okay, so, yan yung location ng resultant force from point A. Okay? So, we'll have more examples sa ibang videos later on.